In this video, we're going to learn how to do work problems. These are problems involving people doing jobs and people doing jobs together. So let me just say working together here. Okay, so let's suppose that it takes a person 5 hours to do a job. So let's say it takes 5 hours to do a job. Now that number is not going to help us very much unless we can turn it into some sort of a rate, right? When we drive somewhere, we say, oh, we're driving at 50 miles per hour, right? So we need some sort of a reference point. If it takes 5 hours to do a job, then what we're going to create is something called a work rate. The work rate is how many jobs you can do per hour. Well, if it takes you 5 hours to do one job, then that means that you do 1/5 of the job per hour. 1/5 of the job per hour. And this goes for anything. So if it takes T hours to do a job, then your work rate is 1/T jobs per hour. All right, now what do you do with that work rate? Well, just like rate times time equals distance, work rate times time is going to equal the amount of the job done. The most being 1, right? Because you can't do more than the complete job. Okay, so work rate times time equals the amount of the job done. Now in these problems, we're going to have more than one person working typically, and so you're going to want to create a table that has this data in it. Okay, the table's just going to look like this. We're going to have person 1, person 2, and then together. Okay. Now, what are the properties of this table? Well, we know that the first column times the second equals the third, so this times this equals this, this times this equals that, and this times this equals that. Okay? And hopefully it makes sense that the amount of the job done by person 1 plus the amount of the job done by person 2 is going to equal the amount of the job that they do together. All right, also the work rates add up as well. So think about it. If I can do 1/5 of a job per hour and you can do 1/5 of the job per hour, then that means together we can do 2/5 of the job per hour. So this plus this equals that. So these are the properties of the table. Let's try an example problem. So this is problem 1. A hot water faucet can fill a sink in 9 minutes, while it takes the cold water faucet only 7 minutes to fill the sink. How long would it take to fill the tank? I guess I should say sink. How long would it take to fill the sink if both faucets were on? Okay, so you've got the hot and the cold water faucet both on. Okay, so we're going to create a table. Again, we're going to have the work rate, we're going to have the time, and then we're going to have the job done. First we have, the first one is the hot water faucet, so hot water. And then we have cold water. Finally we have together. Now, what is the work rate of the hot water? Well, it says the hot water can fill the sink in 9 minutes, so the work rate would be 1/9. The cold water takes 7 minutes, so that means that it fills 1/7 sinks per hour. Sorry, per minute. So, what about the time? Well, we're trying to find the time, so we're going to write let t equal the time it takes both. I'll say faucets, not sinks. The time it takes both faucets to fill sink. Okay. So this is T and that's T. Remember, the amount of the job done is going to be the work rate times the time. So this is going to be T times 1/9, or 1/9 T. This one's going to be 1/7 times T, so 1/7 T. What about together? Well, together they did the whole job, right? It says the two sinks, how long will it take them to fill the sink? So that's one job. So the job done would be 1. If we're using the table this way, by the way, we don't need to fill the 2 boxes here. So now, what's the equation then? This is going to be the equation. Remember, the amount of the job done has to add up to 1. That means 1/9 T plus 1/7 T equals 1. So we have a rational equation here. The LCD is 63. So we're going to multiply the whole equation by 63. We end up with 7T plus 9T equals 63. Or 16T equals 63. Divide both sides by 16, we get T is equal to 63 over 16. 63 over 16. What is that? That's almost 4, right? It would be this many minutes. Or if you want a more concrete, this is 4 and, not 4. 3 and what? 63 divided by 16 is 3. We have 15 left. So 3 and 15/16 minutes. Either answer is okay. You can write it however you like. Okay, let's try another example. Let me read this question. It says, Wayne can clean the carpets in his house in 4 hours, but it would take his son Garth 6 hours to clean them on his own. How long would it take them to clean the carpets together? So this is a very, very similar question to what we just did. Let's see if we can do this again. We have Wayne, we have Garth, and then we have together. So we have the work rate, we have the time, and then we have the job done. So it says Wayne can clean the carpets in his house in 4 hours, so his work rate then would be 1/4 carpets per hour. Garth can do the job in 6 hours, so 1/6. And again, T is going to be the time it takes. This is going to be 1/4 times T, and this is going to be 1/6 times T. And of course, the amount of the job that they do is actually 1. So this is going to be our equation. 1/4 T plus 1/6 T equals 1. Again, we're going to clear the fraction, so the LCD is 24, so I'm going to multiply both sides by 24. So if you multiply it by the first, 6T is left over. By the second, you got 4T left over, and then you have 24. So combine like terms, 10T equals 24, divide both sides by 10. T is equal to 12 over 5. Now these are hours, so we have to put units. 12/5 hours. Another way to write that is 2 2/5 hours. Don't forget, units are very important, right? We could be talking about seconds, minutes, hours, days, weeks. You've got to be specific when you do a work rate problem. Now, this is going to be a tougher problem. This is tougher because we're actually given the together time and also one of the times, and we're being asked for the other. So this is a trickier problem. Let's read it carefully. It says it takes Lily 75 minutes to mow the lawn. When she works with her brother Preston, it takes only 30 minutes. How long would it take Preston to mow the lawn by himself? So hopefully you see the difference in this problem, right? In the others, we were given the individual and we want the working together. Here we're given the individual and a together, and we're looking for the other individual. It's going to be a little different. So let's let T equal the time it takes Preston. Okay, time it takes Preston to mow the lawn alone. All right, we need to fill in our table. We're going to fill it in a little different this time. Not much different, just a little bit different. So we have our work rate, as before. We have our time. And then we have the job done. So let's see. We have Lily. We have Preston, and then we have together. So what's Lily's work rate? Well, it says it takes Lily 75 minutes to mow the lawn. 75 minutes. So that means her work rate is 1/75 of the lawn per minute. How long does it take her? Well, now hold on a moment here. Let me fill out other parts too. Okay, we'll come back to that. Sorry, I was doing this out of order. It says when she works with her brother Preston, it takes only 30 minutes. So the work rate here is 1/30. How long would it take Preston to mow the lawn himself? Well, we know that Preston actually takes T minutes, so his work rate is 1/T. Now what? Well, remember the work rates have to add up too. So we know that this plus this equals this. So we don't even need the right side of the table. Let's write this down. 1/75 plus 1/T is equal to 1/30. And let's figure out how to solve this thing. We know that the LCD of 75, T, and 30 would be 150T. So the LCD is 150T. So now I'm going to multiply everything here by 150T. For the first one, the 75 and the 150 cancel and leave us with 2T. For the second one, the 150 times 1/T, the T cancels, we're left with 150. For the third one, 150 and 30 cancel, we're left with 5, so it's 5T. Subtract 2T from both sides. We get 3T equals 150. Divide both sides by 3. T is equal to 50. That means it takes Preston 50 minutes. 50 minutes to do the job by himself. So he actually works faster than Lily, right? Since it takes her 75 minutes to do it by herself. Interestingly enough, we did not even need the second or third column of the table to do this problem. All right, let's look at this last one. This one is tricky for a different reason. Number 4, a pipe can fill a pool in 8 hours and another pipe can empty a pool in 12 hours. If both pipes are accidentally left open, how long would it take to fill the pool? So you've got a pipe that's helping, another pipe that's hurting. Let's see how we would figure this out. Okay. As usual, we're going to let T equal amount of time it takes both pipes. to fill pool. This is exactly how we did numbers 1 and 2 so far. So we create our table. So 1 is going to be the, let's see, the helping pipe. And 1 is going to be the hurting pipe. Maybe I'll call it helping and hurting, since one pipe fills it where the other one empties it, right? And then we have together. We have work rate, we have time, and then we have the job done. So, the helping pipe, it says, it fills the pool in 8 hours. So this is 1/8. Now the hurting pipe, what do you do with something that doesn't help a situation, but it actually doesn't help? It does the opposite, right? It hurts the situation. Well, if it empties the pool in 12 hours, that means it empties 1/12 of the pool every hour. So the work rate is negative. Negative work rate. What about the time? We know the time is T and T. So this is 1/8 T minus 1/12 T. Oops, sorry, this is negative 1/12 T. Didn't mean to write it there. Finally, the amount of the job they do is the whole thing. So we know 1/8 T minus 1/12 T is equal to 1. So, we're ready to solve the problem. What is the LCD here? The LCD of 8 and 12 is 24. I'm going to multiply everything by 24. So for the first one, we're left with a 3T. For the second one, we're left with a 2T. For the third one, we're left with 24, which gives us T equals 24. So the answer is 24 hours. Which makes sense. We've got something that normally takes 8 hours, but we're actually hurting it by leaving another pipe open, so we expect that this is going to take longer now. And that's it for this video. I hope this has been useful. Thanks for watching.